Hello, my name is Erdem Topsakal. I'm the editor-in-chief of IEEE Antennas and Propagation Digital Communications. We are in Orlando, Florida today. We are with another legend, Professor Raj Mittra. Welcome, Professor Mittra.
Thank you, Erdem.
So my first question is about your background, where it all started. How did you tell us a little bit about your education? How did you get into engineering? How did you get into electromagnetics?
Well, let's start from the beginning. First of all, I was born in the 1930s, which was a Depression era. So people think that somebody who is legend or famous has had everything good all the way. Well, that's not the case for me. For instance, my father passed away when I was 4 years old. So before that, we had a very nice house and nice life and so on because he had a very good position. But then we ended up being very poor. I had to go live with some other family members because we couldn't afford to support all the family. Okay, so I ended up in a place which was very rural India, where there were no cars, no nothing, just bullock carts and elephants. So that was quite an experience, and also no electricity. So that's what I said that I've common with Lincoln, like he studied by candlelight. We did too. But in his case, of course, there was no electric light at that time. In my case, we just couldn't afford it. Anyway, so let's move fast forward. When that part is over, then we went to school, high school, and then college. And college was a town which is well known as Agra, where the Taj Mahal is. Okay, so anyway, in the college, I studied physics, chemistry, basically science and math, and did quite well. But then I wanted to go on to grad school. And before that, in fact, my degree was in sciences, so I wanted to go into engineering because many of my friends, that's where they wanted to go. There was a very good engineering school, and I applied, and I was rejected. And I asked them why. They said, because your eyesight has to be, it's a stupid rule that they had. Your eyesight has to be better than something like that. I said, what for? So in case an engineer sees a cow on the railroad track, make sure that he can see it well. Anyway, I'm just so anyway, I couldn't get into engineering. Okay, so what to do? So I went to another university, which is a very well-known, very prestigious university, and they had a physics program, which was like Harvard, something that competitive like that. For instance, one of the professors there was recognized with Einstein as a collaboration and several other things like that. Anyway, so I went there and I applied to go into nuclear physics because that was the big thing then. It's just slightly after the war, so everybody's into nuclear physics. But I couldn't get in there. They said, no, you got too many applications there. You don't qualify. So what can I get in? This is radio physics, which is a new area they created in that university. And so there were some openings. Okay, so I said, I go to radio physics. Okay, it's not engineering, but it's close to it. So I go radio physics. So I got my degree there, and I did pretty well, got a gold medal, which is very difficult in India. You have to be right at the top, and I was one of the gold medal ones. But then after that, it still was not easy to get a job, because in India those days, electronics industry virtually did not exist. Now it's very different. People go to Bangalore and do all the stuff. So it didn't even exist. So all it did is become a salesperson somewhere. So I said that didn't interest me. So I was looking to maybe further my education, do something different. I applied for a bunch of jobs, didn't get them. So in the meantime, what came along is an opportunity to go to Canada. And to do what? Well, it was a scholarship that lasted 9 months. Okay, and all of India, there was just only one, 300 million people. Of course, not everybody in the engineering sciences. So, but I was able to get that scholarship, and I said I was very happy because nobody from my family has ever been abroad. So then I was very happy that I was able to go, all my dream to go somewhere, abroad and so on. Okay. But there was a caveat. I couldn't afford the fare, airfare, or even in those days, people did a lot of traveling by ships.
Do you remember what year was that?
Yes. It was exactly 1953. Okay.
How much was the fare? Do you remember?
Yeah, I remember. I couldn't afford the fare. First of all, from India, you couldn't go to Canada directly, so you had to go through Europe somewhere, and from Europe to Canada. And altogether, just to go to Europe alone, it was like $1,000. Anyway, I couldn't afford it. So I went back to them and I said, look, I cannot afford it. I'm sorry. They said, wait. We'll make arrangements for you. We'll take care of your travel. So that's what happened. I ended up in Canada. But the question is, what area should I go into? And there, it was, the situation was like this. There were many groups, of course. At that time, my interest was more like circuits and systems. And when I was going through the master's program, there's one area that I hated the most, that was electromagnetics. And why? Because the teacher was the worst ever. So he could go to the blackboard and do something, and then it gets stuck, and we had to help him. So circuit system, on the other hand, the person was young and so forth. So I wanted to go to circuit system. But at the University of Toronto, where I ended up, there was no opening in circuit system. There was, however, an opening in the Antenna and Electromagnetics group. I said, okay, I'll go for that. But I didn't know how well I'll be able to compete with the, because my education is in India, and obviously I assume that everybody in Canada or UK or somewhere else is much better educated than I am. But it turns out the qualifying exam, I was able to get 100, which was the top score. So I felt more confident. Anyway, my advisor, he was very busy. So that's the kind of thing that kind of forced me to be self-sufficient. Fortunately, I had some postdocs there who helped. Those are the greatest years. The first of all, being in a different country, but Canadians are fantastic hosts. And they took me in just like I was part of the family and so on. Okay. So 3 years, I finished my PhD. I looked for a job, and I applied to the University of Illinois because that's where my advisor's friend, Dr. Jordan, was the head of the department. He was the head of the antenna department. I said, that's where I want to go. I didn't hear from him. In the meantime, someone who also knew my advisor well was really desperately looking for people who could teach because he was really short of people. Okay. As a footnote, my first job there, which was at Penn State, okay, the salary was $4,000 for 9 months, not $4,000 a month. But of course, still it was 3 times better than what I was doing as a grad student stipend. But remember, peanut butter sandwich was 10 cents. So those were old times. Anyway, so I ended up at Penn State, and then they gave me a teaching load, 4 courses, and I was just totally stressed out, trying to teach and so on, because you said something about teaching. So I applied again to Illinois, and what had happened that last time, Jordan was on vacation or something, so by the time he replied, it was too late. I already had accepted the job. So then I switched to Illinois. And Jordan was a fantastic mentor. And you ask about, when you get there, of course, as a professor, you're supposed to teach, but it's the teaching there at Penn State, the load just that killed me. So here, on the other hand, Jordan, as I said, was a fantastic mentor. And he said, okay, you just teach 1 course instead of the regular 4 courses with the full load, and you do research. And he helped me all along, was a fantastic mentor. So that's how I got into the Illinois and research, and Illinois turned out to be it was among the top 5 in the nation in engineering at that time, and even now has maintained.
You started talking about research, of course, as part of the academia. We have to do, especially when you're research active. Not only we do teaching, but also we do research. So you took us back to these days. So how was research? In late 50s and all that. So you said that you had mentors, helped you out, and all that. Of course, I'm sure it's different times, different types of research and all that. So can you describe us the research environment? How did you start? Did you need equipment to start with, or theoretical? We know that you have done a lot, contributed a lot in the theoretical electromagnetics as well. If you can summarize those things.
Research environment was quite different at that time than it is now. In which way? Now it's very competitive. So you write a proposal, and I say only 1 out of 10 proposal gets through. Illinois had the fantastic opportunity because they had a dedicated program from the Air Force lab in Ohio, okay, Dayton. We had a contract, long-term contract, to do research on antennas. And so I was able to join that group. In the beginning, I didn't have to fend for myself to go look out for it, because it was already there. And that made all the difference in the world, okay? As far as the facilities goes, since you mentioned that, I should mention at the University of Toronto, my main research on the PhD program was not highly theoretical. There was a lot of experimental work. And my mentor was, I don't know if you know, Jim Waite. Someone who read more than 1,000 papers. He was my mentor. He had a project from PRB. And the reason I mentioned that I built something like a poor man's anechoic chamber there, did all kinds of things like that. When you look at my paper, mostly it's theoretical, that you would know that I started out by doing experiment. And I remember there was no network analyzer. So we have this probe that went into a slotted waveguide, and you measure standing wave ratio that way. But things were very different in Illinois, at the University of Illinois. The antenna lab was well equipped, and they had a pattern range. They had all kinds of technicians building antennas, testing antennas, and doing all this sort of thing. So that's one thing. But also, this is quite important. What happened at Illinois, that I was able to publish. Remember, Jordan gave me kind of free hand, a lot of time and so on, less teaching her. So I took advantage of that. I published. Why that's important is because people, both government as well as industry, started coming to me, asking me to work on their project. So I didn't have to go submit proposals and whatnot. And that made all the difference in the world. Sometimes they will come and I will ask them, why did you come to me? You know, that it's a big country. There are a lot of universities doing work like this. Almost always the answer was, oh, I saw your paper and this is something we're very interested in. So the publication, actually, people do it because, you know, they get promoted in the lab. In my case, it was very different in terms of the impact of the publication. It was because that's how people started coming to me. And this was, to me, extremely important because I learned new things to work on new areas and so on. Because sometimes, one time, for instance, somebody came to me, they wanted to work on a packaging problem. I said, I don't know anything about packaging problem. I said, don't worry, we'll teach you. We know that you've done computer programs to do this, that, and other thing. And so I learned packaging by working on those kind of projects. That's an example. And the second thing is that I started developing computer codes because that was very popular thing to do at that time. And it didn't always have to go to government, NSF or something. Companies came to me and said, develop a computer code to do this. Why that's important is because even companies from UK, France, and so on, they started coming. They would come to Urbana to talk to me and acquire these codes. And one time from UK, the British Aerospace, the guy who was the chief there, research person, came to visit, and he asked me what codes I have. I presented them. He said, oh, that's about 10 different codes I had that time. I said, we'll get them all. I said, what? Anyway, that was my first big sale, and it was enough money to buy 2 Rolls Royces.
Wow.
So that's something, again, it's not just the publication aspect. It's what to get promoted, you know, that kind of thing. It's also working with the industry is a fantastic thing that I think is not very common with other faculty members. They do their research, they publish, and they get promoted and so on. But consulting, at least at Illinois, unlike Stanford or some of the other places, wasn't all that popular. I did a lot of consulting. People came to me and I said, okay, I can help it, and so on. And sometimes it'll be some of my former students who have gone on, and they will come to me. So it's very important to keep good relationship with your students, right?
So, of course, you have been involved with IEEE throughout your career in the academia. Can you describe us how IEEE Antennas and Propagation, how early on you're involved in these activities, how it impacted your academic career, different conferences, meetings, publishing, IEEE APS journals. I guess transaction APS was not APS before, you published on probably
That's right.
earlier.
That's right. It was a professional group of antennas, PGAP, professional group of antennas and propagation before it was APS. And I have been at the APS symposium, or what preceded APS, the PGAP meeting, ever since the first one, or every one of them. Okay. And things were very different, much smaller, of course. What people did is went to special sessions, and the IEEE had a major meeting every year. It was in Waldorf Astoria Hotel in New York, and they had different groups, professional groups. So that's what I did before it was PGAP. Then after PGAP, of course, as I said, I participated participated every single one of them. Okay. Furthermore, I also, not only I contributed, I encouraged students to go present papers and things like that. And as I also mentioned, the publications had the impact of, it drew attention of people through the symposium. They will have, of course, people from the industry attending. So I'll network with them, and often they will say, okay, we heard your paper, we want help on such and such problem. So I had many such occasions. So APS meeting was my thing. I always religiously attended that. And of course, it has evolved since then. And the last one in Florence was a fantastic celebration of 75th anniversary, which I was fortunate to attend.
Of course, it did grow throughout the years. So from humble beginnings to thousands of people attending and all that, in the thing. My next question about you have published many books, you have advised many students. Can you talk about the books?
I think I've published either as editor, contributor, or more than 30 books, maybe 35 or so. It's not just the number, it's the kind of book. So for instance, the very first book on computational electromagnetics. So I was a contributing editor to that, and many of the famous people, including Harrington and others, they contributed to that. Ed Miller, right, and various other people like that, Don Wilton, so forth. So then after that, there was one book where I was just contributed to a chapter I was very proud of, which is, I mentioned I was at University of Illinois, and they were doing work on log periodic antennas and so forth, and I was involved in that and wrote many papers. And one day, it was like I was still in bed because of the time difference. I had this phone call from Bob Collin. He said he and Zucker's from Air Force, they were editing a book and they wanted me to contribute a chapter in that book. That was my very first thing, in fact, before the computational EM book I'm talking about. And there were many people working in that area. So I was very proud that they would ask me. And I think I did a pretty good job, and I got to know Bob Collin well through that. So that's about the book. Since then, many other followed by invitation sometimes. Sometimes I would put together a bunch of authors and on a thematic thing and do that, and it would be published by IEEE was one of the publishers, and Springer. These people were scientific publishers. Now let's talk about papers a little bit. If you do a Google search, you'll see that I have more than 1,000 papers, okay? The important thing is that if you look at these papers, how as times change, the topics that I focused on also change, okay? You mentioned GTD. GTD was a big thing, right? Because of Keller, and many people were working on GTD. At that time, that was the only way to do large body problems. There was no other way. I mean, Harrington, interestingly, when he wrote that paper on moment method, he got rejected by AP. And I know that because I was one of the reviewers, and I recommended, okay, because I said, this is very interesting. Okay, it's novel, is different. Anyway, so he published it somewhere else first. Now, of course, it's something that has proven itself as one of the most popular. So the reason I mentioned that is how things evolved with time. Before that, it was people did the three-term sinusoidal and so on. And I should mention at this point R.W.P. King, who also had 100 PhD students, but I think I exceeded him. But again, not the number. If you look at what these students have done and gone on. The reason I mentioned R.W.P. King is because he had the three-term sinusoid, and that's what people were basically sold on, because he's written many, many papers. So moment method was totally different. And that's something that I think is a lesson to learn. And I was an editor, APS transaction editor one time.
So on the topic of different topics in research and all that, so where do you think electromagnetics research is going on with new AI and, new things being introduced and all that? How do you see it next 10, 20, 30 years?
Okay. Then, since you asked that question, I should mention that IEEE did a test, kind of asked some of the fellows, famous in their own right, to predict what's going to happen 25 years from now. They predicted, but most of them did not really hit the mark. Okay. And the reason I mention that, this field is evolving continuously. 25 years ago, nobody knew anything about AI. Now everybody is talking about AI. Okay. And likewise, things such as machine learning and various kind of optimization, so on. But my point is, or is it maybe quantum level thing, it's driven by two things. First of all, the development and progress in the computational capability. That's continuously, we're seeing the advent of GPU, the landscape has changed.
Yes.
And so on. So I think that it's basically driven by where the field is going. As for instance, right now there's a lot of focus on 5G, 6G, etc. For sure, that's an area that's going to grow. And therefore, we need to have computer programs and modeling capabilities, measurement capabilities, prediction of propagation capabilities, tailored for millimeter waves and above, and maybe terahertz. Okay, so I can name all of these things, but again, I don't know 25 years from now what's going to, but I think the field automatically adjusts.
I guess the important thing is you have to adapt yourself.
This is the key point. If you're not doing that, then you're dead. That's the key point. So, yeah, what's important for the students, for instance, is to learn the physics well and to keep an open mind to be able to switch areas. If you get hung up on one area, maybe the same thing that you do your PhD thesis on.
Actually, this is a great segue to my next question, which has to do with what advice would you give to the next generation of students, professionals and all that, which you started already saying that, try to adapt, evolve.
First, let me tell you how I selected the students. So most of the time, I didn't recruit students. They would come to me. And I'll tell them, listen, I don't really have an opening, but I'll tell you what, why don't you join the group and I'll give you a project to work on. I'll see how you do. And it's kind of and you'll see whether or not you like to work on that project. Okay, that worked out to be a paradigm that enabled me to find good students. And what I looked for, very important, is the attitude of the student. Okay, if, for instance, as everybody does, make some mistake, rather than trying to defend it, if he admits it and learn from it, then that's the right attitude. And again, I didn't recruit them as many with the fellowships from many different countries, they would come. Okay, so, but in order for that to happen, you have to create an environment that's challenging, yes, but also interesting, and something you have to help them. Sometimes the student will have a personal problem. One time a student comes to me and he says, he's a PhD student, a very good student. And he says, he cannot continue. I say, what? You're almost, close to the finishing. Why can you not continue? He says, my mother is sick and she needs help in terms of money, which I cannot send to her, so I'm going to go get some work, some job, make money, and so forth. So I helped him, and he stayed and he finished, and he's quite successful. Okay, so as far as the advice to the students, it's very important to have the right attitude, okay, and willingness to learn. People make mistakes, learn from your mistakes, and admit it rather than trying to be defensive, okay. And very important is that since the field is evolving, have an open mind to learn new things. And speaking of learning new things, I learned a lot of new things from my students. How? For instance, I had a student, he's University of Michigan now, is Eric McCallison. And he had some friends that were working on this optimization programs, and his friends were in mechanical engineering. I didn't know anything about optimization program at that time. I hadn't worked on it. But he said he wants to work on it. I said, fine. So I encourage students to go look into areas, right, that are novel, that are different, and so on, in which I may not have the background. Doesn't matter. I said, you do it. So he did that. That's how I got into optimization and learned, and even wrote a book chapter for a book that Yaya edited on optimization. That's just example. And who knows, tomorrow will be another field, right? So that's something that's very important, to keep an open mind and to be willing to learn.
That brings me to my last question, which is what does Dr. Mittra do outside of the office? So you spend your entire life, dedicated your life to educating students, doing all these research, electromagnetics and all that. How does it look like outside here?
As a tennis player, I would say that I played 8 days a week, meaning I played every day and twice on Sunday.
Wow.
So I was an avid tennis player. And in the winter time, either I will go indoor course or play squash. And I always had tennis partners, always. And that's another thing to do. And it's a great relaxation. So come time, 5 o'clock, I'm out the court every day. Okay. So now, of course, I'm no longer able to keep up with tennis or pickleball or whatever. So now, come 5 o'clock, I'm at the gym every single day, 7 days a week. And that's very important to clear your mind and think about something totally different. Okay. But for recreation, I love music. I go to plays. And very important, I love to travel. Okay. As an example, just the last 2 years alone, I've been to Tahiti, Antarctica. I've been to Iguazu Falls in Brazil, 5 different cruises to different places, and so on. So I love to travel. Before, it used to be just when meetings, at least once a year to a foreign meeting, and of course domestic as well. For me, it's also interesting that I have a group of people who are scattered all around the world that I work with. And that's also very helpful, okay, in 2 ways. One, you're helping them, you're mentoring them. They're scattered all over the world, and even if they have questions, they talk to the professor, and So they can't get the help. Okay, so they come to me. So this is another way to relax. And that's, to me, is one of the key things. Let me quote Steve Jobs. He was asked, what's important in life? And he said that, listen, you drive a fancy car or an ordinary car, your starting point and the end point of the destination is the same. You just get there, right, at the same place. Whether or not you're carrying your money in a fancy wallet or a regular wallet, it's the same amount of money, etc., etc. He says, what is important is to create good relationships. Okay? And to me, that's the bottom line. You do things that make you feel good. For me, one way I feel good is by donating monies to various universities. The 3 universities, Illinois, Penn State, and UCF, I've given them about $5 million each. And I've also pledged more. IEEE, I have also. And I was telling, I was in a award dinner. They were recognizing people at Illinois who was giving money. And I was talking to the person there from the development office. I said, sometimes people ask, why do you do this? I said, well, it was a short answer. It makes me feel good that I'm doing good to somebody, changing their life and so on. And that's the key. That's the bottom line. Do something, feel good by doing some good to somebody.
You know what they say, when you ask for something, you may not get it. You ask for promotion, you might not get it. You ask for salary raise, you may not get it. But if you want to give, no one can stop you, right? Giving is the most joyful thing.
But the thing is that the impact that it has. They send me pictures of people who receive the awards and so on. So I have all these things, and they've done many, many things with that scholarship.
Well, thank you so much. This is the end of our interview with Professor Raj Mittra. Until next time, stay happy, stay healthy.